Hello everyone, welcome to Concept Cracker. We are back with a new video of our cracking Java course. What we are going to discuss today are pseudocode, compilers, interpreters, and also the difference between them. Now, let's talk about pseudocode. Pseudocode is a text-based description of the steps in an algorithm. It allows programmers to express the design in great details. It is much easier than writing a coding language. It is intended for human reading and not machine reading. For better understanding, let's see an example. Now, if we are given a question, count number of students passed and failed. So, by flowcharts, we know that first we start our flowchart, then we read the marks, then we check is marks greater than 30 or the passing marks. If it returns a yes, then student passed. If it returns a no, then student failed. And then we stop our flowchart. But to express this design, pseudocode comes in action. Now let's see what's the pseudocode of this program. First we initialize the number of passes to 0. Then we initialize number of failures to 0. Then we initialize number of students to 1. Please keep in mind, we can't initialize student to 0. When a exam is not happening, then we can initialize passes and failures to 0. But when we are initializing a student, then it can't be a 0. Now we have to find the result of 10 students. So we use a condition that while number of students or the student counter is less than or equal to 10, we input the exam result. If the result is greater than the passing marks, then we add 1 to the number of pass. And if it's not greater than the passing marks, then we add 1 to the number of fails. Then we add 1 to the student counter to increment the number of students. After returning from the condition, we print the number of passes and the number of failures. Now let's talk how does the code run inside our computer. First of all, we have to write the code in a code editor. We will be having a lecture on the setup of a code editor very soon. This code, which is written in the code editor, is also known as source code. From there, we compile the code into machine language or binary code using a compiler, and the compiler turns that code into machine code or the binary code, which is 0 and 1. Next, we have compiler. A compiler is a special computer program that translates a programming language or source code into machine code. Now, compilers are of three types. Single pass compilers that passes through the part of each compilation unit exactly once. Two pass compilers that passes the source code multiple times, and multi-pass compilers, they are used when we want to design a compiler for different programming language in a same machine. We don't need to know about them according to this course. Next, we have interpreter. An interpreter is also a special computer program that directly executes instructions written in a programming language without compiling them to machine language previously. There are four types: bytecode interpreters, threaded code interpreters, abstract syntax tree interpreters, and self-interpreters. Again, we don't need to learn the details about the types for this course, but you can just Google them for your own research purpose. Now, let's talk about the differences between compiler and interpreter. A compiler translates the whole source code in one go, whereas an interpreter translates the code line by line. A compiler is suited for production environment, whereas an interpreter is suited for a development environment. A compiler generates an intermediate machine code which takes much time, whereas interpreter takes less time because it never generates the intermediate code. And as you can see, compilers are used in Java, C++, C, and interpreters are used in Python, PHP, Ruby. Now, here's the catch. Both compiler and interpreter have their own preferences and use cases. So we can't declare one better than the other. That's it for today. Thanks for watching.